name is Phil Willey, and here with Beth Heary as well. And today we will be presenting on aspiration designs and specifically aspiration for dusts in general. So there you go. So just a quick agenda. So we're going to start with essentially dust aspiration design 101, introduction to aspiration design, ACGIH, what that is. We'll go through what transport velocity, pickup hood velocity, and constant velocity design approach. We'll talk about balancing a little bit and the importance of that. We'll talk about dust collectors, dust collection 101. We'll go through some explosion protection and isolation techniques in case you have combustible dust. And we'll talk briefly about what SMACNA is. And then we'll go through a few kind of bad aspiration design examples for ducts. And then at the end of the presentation, we will talk a little bit about typical aspiration designs for truck loadout, conveyors, bucket elevators, how to get aspiration CFMs for those equipment. Then we'll just touch briefly on moist dust designs as well.
Good afternoon. My name is Beth Heary, and the first thing we're going to take a look at is a good overall, if you've never looked into aspiration and industrial ventilation, ACGIH has a very good recommended practice book to take over and look at general recommendations, good practices. They have information regarding methodologies and specific designs that are adjustable to specific hoods and exhaust practices over their 30+ editions. So on this picture, just to take a bit of a look, you have in the upper left is kind of a slot hood table that can be used if you are dumping bags, if you are using, they can be modified for bag dumping. Although in a bag dump, we would want to go to that midsection, which we would prefer a downdraft hood, because that keeps any dust out of your breathing space. Whereas a slot hood will also, but if you were to put your aspiration above those, then you would pull any dust that was generated past your breathing zone before being aspirated, which you don't want to do. The left picture on the bottom is just a representation of a tank that you might be gravity filling. And you take off your aspiration from there to minimize any dust accumulation in that head space, which we'll talk about a little bit later, why you don't want to have dust in those head spaces. The ones over to your right are just other looks at slot hoods. For instance, the third to the right is for aspirating drums, if you're using those, and then another look at a slot hood that's commercially available. So the next thing we're going to take a look at is when we want to pick up dust, we need to capture it. We want to capture it, but we don't want to take up too much airflow, more than we need. And the interesting thing here is you've got a bunch of different types of hoods, and they type varies on that distance. So we look at our location of X, and then you look down to another location of X. And depending on the hood that you're using, that can be anywhere from a direct multiplier on the distance to a squared multiplier on the distance. So as you can see, depending on the hood that you're using and your dust source, you can get very high airflow requirements pretty quickly. So you need to take a look at what your dust is. So the big thing with aspirating dust is you need to understand what that dust is. What kind of settling velocity does it have? What kind of pickup velocity does it need to get it into the air? So that you can decide if you need to capture it or let it settle before you capture just the remnants of the less dense and less heavy portions of your dust. And the things to think of there are the distance from your contaminant